All right, we're going to do the second free response problem from review day 16. We're given this cylinder, and we're told that the height is changing at this rate here, and we were given the volume for a cylinder here. A says find the rate of change in the volume with respect to time when the water is 4 feet. So one thing that they didn't do, which we kind of have to understand, is that the radius of this cylinder is 1 and always 1. The radius is not changing for this problem. So as when we go to look at our volume, if you keep it as a variable, it makes it much more difficult. We can have the volume for our particular cylinder to just be pi times 1 squared times height. And that makes life a whole lot simpler, especially for part A. Because now we're going to take the derivative. dv dt is equal to pi times dh dt. And at 4 feet, if I put 4 in for h, I get negative 1/10 times 2, which is a negative 1/5. So I get a negative pi over 5, and it's cubic feet per second. So you got 1 point for having the correct derivative here, and 1 point for the answer with the correct units. All right? So again, not too bad, but if you didn't make that switch with the r, then that complicated things for sure. Now, part B says when the height of the water is 3 feet, the rate of change of the height is it increasing or decreasing? So the way we would know if the rate is increasing or decreasing is by looking at its derivative. So in other words, we have to take the derivative of this. So second derivative is going to equal negative 1/10 times the derivative of h, which is 1/2 h to the negative 1/2 times dh dt. And so that's going to give us a negative 120. This h to the negative 1/2 is 1 over square root of h. So I'm going to put that down here. And then times dh dt, which is negative 1/10 times square root of h. Okay. Now, when you let these cancel, what we end up with is 1/200. So the second derivative for our problem is always 1/200. It doesn't matter where h is, right? So it doesn't matter that it's 3 feet. It could be 1,000,000 feet. Don't care. The second derivative is always 1/200, which is always positive. Therefore, the rate is increasing. Okay. So they gave us 1 point for doing the derivative, the initial derivative. They gave us another point if we could kind of work out that second part, and then a point for having the correct conclusion. All right? So if you can kind of just stay organized and you know how to simplify that, this problem wasn't too bad. All right, then part C is our separation of variables problem, and so now what we want to do is bring this square root of h over. So we're going to have dh over h to the 1/2 equals negative 1/10 dt. So if you did your separation to start with, that was a point. Now we're going to integrate, and when I do that, I'm going to bring this up as h to the negative 1/2 equals negative 1/10 dt. This is going to become h to the 1/2 over 1/2 equals negative 1/10 t plus c. This obviously becomes 2. But if you do those integrals correctly, you got a point. Now we want to put 5 in for h and 0 in for time. We're going to get 2 times the square root of 5 equal to c. So if you had that, if you were able to put those in and correctly get c, that was worth a point. And now our last point is if we can get h by itself correctly. So I get plus 2 square roots of 5. We're going to divide by 2. So if you want to just leave it like this, it's going to divided by 2, and then square everything. And this would get the job done right here. All right. If you want to make this negative 1/20 and just square root of 5, divide it out by 2, that's up to you. But that would be worth our final point on that.